Hello everyone. Science Plus TV has come up today with a very important topic from the chapter Hydrocarbons, and the topic is halogenation of alkanes. Alkanes are the simplest type of hydrocarbons which shows many kinds of reactions. Substitution reaction is one of them, in which one of the hydrogen atom or one or more of the hydrogen atoms are substituted by some other elements. Okay, so when they are substituted by some halogen, the reaction is known as halogenation of alkanes. Why today I have taken this topic? Because students, this topic is interesting as well as important for exam point of view, especially its mechanism, which I will discuss in the very next video. But first we will just get introduced with this halogenation of alkenes in this video. So what is halogenation? Halogenation of alkenes is one of the important substitution reactions which is shown by the alkanes. Now how is it done? This reaction is carried out by heating any alkane with suitable halogen atom at a temperature of 520 to 670 Kelvin. There is another method. We can also carry out this reaction by treating the reaction mixture with UV light, ultraviolet light. The halogens, that means fluorine, chlorine, bromine and iodine, they show this order for the reactivity in showing halogenation. That means fluorine show it rapidly, then chlorine, then bromine and then iodine. Okay, so let's take one example. Here I have taken the example of chlorination. The molecule of methane is taken here. You can see CH4 is methane. When it is treated with the chlorine gas in the presence of ultraviolet radiation, or we can provide the heat, the temperature up to from 520 to 670 Kelvin, one of the hydrogen atom is replaced by the chlorine and it forms methyl chloride, or you can also call it chloromethane. Let's write. Chloromethane is its common name and methyl chloride is its IUPAC name. Okay. Then this chloromethane will further undergo halogenation, that means chlorination. It will further react with the chlorine under the same conditions, and it will convert into dichloromethane, that means methylene chloride, CH2Cl2, and one more molecule of HCl is released. Then this dichloromethane will again react with another molecule of the chlorine under the similar conditions, which will give us the trichloromethane, or that's a very interesting compound, chloroform. You must have heard about chloroform. Now you know what is chloroform actually. The chloroform is trichloromethane. Okay. One more molecule of hydrogen chloride, that means hydrochloric acid, is released. Then this chloroform CHCl3 will finally react with chlorine under same conditions to give us the tetrachloromethane or carbon tetrachloride. This compound is also very important. Let's write its name, carbon tetrachloride. Okay, so one more HCl molecule will be released. Now you must have observed that this reaction continued till all the hydrogen atoms are replaced from methane. Okay, all the 4 hydrogen atoms are replaced finally by the chlorine, and this reaction is continued till that end. This happens due to a very interesting and important mechanism which this reaction undergoes through, and that mechanism definitely I will discuss in my very next video. Okay beta, so I hope you enjoyed understanding about this halogenation. See you later in the very next video. Thank you.